Hello, Miss Thinker here, your daily source for mind-blowing facts, forgotten history, and powerful motivation. Today, I will talk about the universe. What if I told you that everything you've ever known, every person, every planet, every star fits inside something so vast that the human mind struggles to imagine it? Today, we're re-asking one of the biggest questions science has ever faced. How big is the universe? To answer it, we'll travel from Earth to the edge of what we can see, and finally, to what might lie far beyond. Let's begin where we are. Earth is about 12,700 kilometers wide. Sounds big, right? But Earth is tiny compared to the Sun, which could fit over 1 million Earths inside it. And on an even grander scale, our entire Milky Way galaxy, along with thousands of others, is being pulled towards a mysterious unseen mass known as the Great Attractor, located hundreds of millions of light years away. Its immense gravitational pull gives us a hint of the massive, hidden structures that shape our universe. And our Sun? It's just one star in the Milky Way galaxy, which contains over 100 billion stars. If our galaxy were the size of a city, our solar system would be smaller than a single grain of sand. Already, things are getting hard to picture. The Milky Way is about 100,000 light years across. A light year is the distance light travels in 1 year. That's nearly 9.5 trillion kilometers. Many of these stars will end their lives in a supernova, a cataclysmic explosion that briefly outshines an entire galaxy. These explosions are cosmic forges, creating heavy elements like gold, oxygen, and carbon and scattering them across space. The very atoms that make up our planet and our bodies were born in the heart of a dying star. Even traveling at the speed of light, it would take 100,000 years just to cross our galaxy. And here's the shocking part: the Milky Way is not special. Using powerful telescopes like the Hubble Space Telescope, scientists discovered that the universe contains billions of galaxies. Each galaxy holds millions to trillions of stars. Then came the James Webb Space Telescope, which revealed even more galaxies, some formed just after the universe began. And within these galaxies lurk even stranger objects, black holes. These are regions of space-time where gravity is so strong that nothing, not even light, can escape. Supermassive black holes are found at the center of most large galaxies, including our own Milky Way, and we can now detect the most violent cosmic events like the collision of black holes through gravitational waves. These are ripples in the very fabric of space-time predicted by Einstein a century ago. Detecting them has opened a new era of astronomy, allowing us to hear the universe in a way we never could before. Every tiny dot you see in deep space images? That's not a star. It's an entire galaxy. Let that sink in. Now here's where it gets really mind-blowing. Scientists can only measure the observable universe, the part of the universe whose light has had time to reach us. The observable universe is about 93 billion light years wide. But wait, the universe is only about 13.8 billion years old. This expansion began with the Big Bang, a moment 13.8 billion years ago when the entire universe was compressed into an infinitely hot, dense point. In a fraction of a second, it exploded outward, creating space, time, and all the matter that would eventually form galaxies, stars, and us. How can it be bigger than its age? Because space itself is expanding. To explain the incredible uniformity of the universe, scientists have proposed the theory of cosmic inflation. It suggests that in the first fraction of a second after the Big Bang, the universe expanded faster than the speed of light. This period of hyperexpansion would have smoothed out any initial irregularities, creating the vast, flat, and evenly distributed cosmos we see today. We can even see the afterglow of the Big Bang. This is the cosmic microwave background, a faint light that fills the entire universe. It's the oldest light we can detect, a baby picture of the cosmos when it was just 380,000 years old. This radiation is a crucial piece of evidence for the Big Bang theory and tells us about the universe's age, composition, and evolution. After the Big Bang, space began expanding, and it's still expanding today. Galaxies aren't just moving through space. Space itself is stretching. Some galaxies are moving away from us so fast that their light will never reach Earth. This vast, expanding space leads to another fascinating idea: wormholes. Theoretical shortcuts through space-time, they could potentially connect distant parts of the universe, or even different universes. While purely hypothetical, they represent our quest to overcome the immense distances that separate stars and galaxies. They already exist, but we'll never see them. Here is the biggest mystery of all. The observable universe might be only a small fraction of the entire universe. Beyond it could be more galaxies, endless space, or something completely unknown. Some theories suggest the universe could be infinite, part of a multiverse, or shaped in ways we don't yet understand right now. Science simply doesn't know. But the mysteries don't stop there. Everything we've discussed, all the stars, galaxies, and planets, makes up only 5% of the universe. The rest is invisible. About 27% is dark matter, a mysterious substance holding galaxies together. And what about the idea of a multiverse? This theory suggests our universe is just one bubble in an infinite sea of other universes, each with its own laws of physics. Our ability to explore these questions has been revolutionized by the discovery of exoplanets, planets orbiting other stars. Thousands have been found, from giant gas worlds to small, rocky planets like Earth. Some are even in the habitable zone, the right distance from their star, where liquid water, a key ingredient for life as we know it, could exist on their surface. Some might be similar to ours, while others could be unimaginably different. The multiverse remains one of the most debated and exciting ideas in modern cosmology. This leads to a profound puzzle known as the Fermi paradox. If the universe is teeming with billions of Earth-like planets and life is not unique, then where is everybody? Are civilizations rare? Do they destroy themselves before they can explore the stars? Or are they hiding from us? This silence is one of the biggest unanswered questions in science. And a staggering 68% is dark energy, the force accelerating the expansion of the universe. We can't see them, but they dominate everything. This leads to a philosophical puzzle known as the anthropic principle. The laws of physics in our universe seem to be finely tuned for the existence of life. If any of the fundamental constants were even slightly different, we wouldn't be here to observe it. Does this imply a deeper purpose, or is our universe just one of many in a multiverse, where we simply happen to live in the one that could support us? It's a question that blurs the line between science and philosophy. And what could be the ultimate theory that unites all these ideas? One leading candidate is string theory. It proposes that at the most fundamental level, everything is made of tiny, vibrating strings of energy. This elegant but unproven theory could be the key to a theory of everything, uniting the laws of the very large and the very small, and perhaps explaining the deepest mysteries of our universe. And with so many planets out there, it raises another profound question: are we alone? The search for extraterrestrial life is one of the most exciting frontiers in science. Telescopes are scanning distant exoplanets for signs of atmospheres, water, and maybe even life itself. The answer could change everything we know about our place in the cosmos. So where does that leave us? On a tiny planet orbiting an average star? Inside one galaxy among billions of others? Yet here we are, able to question, measure, and understand the universe itself. The universe may be unimaginably vast, but the fact that we can even ask how big it is might be the most incredible thing of all. If this video made you feel small but inspired, you're not alone. Because the universe isn't just something we live in. It's something we're learning to understand. Finally, how will it all end? The ultimate fate of the universe is still unknown. Will it expand forever, leading to a cold, dark, big freeze? Or could it collapse back in on itself in a big crunch? Or even be torn apart by dark energy in a big rip? The answer depends on the very nature of space and time. If you enjoyed this journey through space, like the video, subscribe, and comment. Do you think the universe is infinite? See you in the next cosmic mystery.